So hello and welcome everyone to another video from PyNet Labs. So in this video, we are actually going to talk about EIGRP metric calculation. Okay, so we know like metrics are a great part or like a very important part when it comes to routing. So before we deep dive, before we jump into this discussion, before we start with this topic, I would like to discuss a few things about metric. So metric, in simple terms, is kind of like a factor that is generally used by the routers in order to determine the best route. So whenever a router has multiple routes, so it actually goes through a couple of steps in order to determine like what will be the best route in order to reach a destination. So say if I have router one somewhere here, and say I want to communicate with router number two somewhere here, and say in order to reach from router one to router two, I may be having like multiple routes. So let's say I have a route number one, and say I may have something like a route number two here, and I may have route number three over here. Okay, so since I have like multiple options, and this is the norm of the networks in today's network. So we all know like in today's network, we do implement something that is known as redundancy. So we may have like multiple links or duplicate links in order to reach a certain destination. But most of the time, out of all the links that are available to us, our routers or whichever router might be responsible for routing our data only relies on a single path. So when it comes to multiple options, so how can my router determine like out of the three options, which one is the best one? So when it comes to select the routes, the routers actually go for few things. So they first of all look for directly attached network. Okay, or we can say they look for directly attached routes. Okay.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
And the second one here, they compare the route with the lowest AD value. So they look for the routes that have the lowest AD values. And the third one is something they compare the lowest metric. Okay, so they always go for the lowest metric. So if a router has three options, so the first thing it is going to look for, it is going to look for any directly attached, or we can say some locally attached route to the certain destination. So in this case, as we can see, we don't have a local connection to the destination. So what it does, it looks for the route with the lowest AD values. Now, depending upon your routing protocol, you guys can like say you can configure RIP, you could have configured EIGRP on your network, you could have configured OSPF, and you could have configured something that is known as BGP. So depending upon the routing method that you use, or what there's one more, you can also go for the static. So depending upon the routing method that we are using, so say static routes has an AD value of 1, RIP has an AD value of 120, and so this is kind of like a quiz. So I'm asking you guys to share what is the AD value of EIGRP. And if we come to OSPF, we have 110 as the AD value. When it comes to BGP, we have 20 for eBGP and we have 200 for iBGP. So these are separate AD values that might actually help the router to determine which route is the best. So if you have configured static routing, then static routing will be used as it has the lowest lowest AD value. If you have configured RIP as well as OSPF, now out of these two, OSPF will be preferred because OSPF happen to have a lower AD value. And if you configured BGP with OSPF or RIP, so say I have configured the first route as a RIP route, the second route as the OSPF route, and the last route as eBGP or let's say eBGP route. So out of the three, the third route will be preferred because it has the lowest AD value. So that's how the routers, they actually do determine how to select the best route. Okay. And if all of the three factors, let's say the AD value or say the metric is the same, then the router does something that is known as load balancing. So in case, which is really rare, the router might use something that is known as load balancing. So that means it might simultaneously use all the available routes in order to reach the destination. Okay, so but here we are not about talking, we are not into talking like how other routers perform or how the metric is calculated for other routing protocols. Today here we are going to focus on something that is known as EIGRP metric calculation. So before we jump onto the formula that we generally use to calculate the metric, there are a couple of few things that I think we should know. So as you all know, EIGRP uses something that is known as composite metric. Okay, so what it meant by composite metric is that it not only relies on a single factor, but it actually relies upon multiple factors. So when it comes to the metric, like how the metrics are evaluated for EIGRP routes, we have like two options. So we have something that is known as constant K values, which remains the constant throughout your implementation. Then we have something that is known as network variables, which might change depending upon our connection or our network. So when it comes to the constant K values, we have like K1, we have something like K1, we have something like K2, then we have K3, then we have K4, and at last we have something like K5. So by default, K1's value is 1, K2's value is 0, K3's value is 1, K4 value is also 0, and K5 value is also 0. So these are the default values. Now, as a network administrator, you have the opportunity, or like say, you have the means to change them. So if you want, you can change the K values for your network. Now, coming on towards the network variables, uh, EIGRP considers certain network variables like bandwidth. Then it considers something as the load. Then it considers something as the delay. Then it considers something as the reliability, and then it considers something as the empty. Okay, so these are the few things that EIGRP, whenever you enable EIGRP on your router, so your router does the calculation in order to calculate the metric, or in order to find the metric, in order to reach from source to the destination. These values are generally compared. Okay, so the constant K values also mention like which of the network variable we are actually focusing on while doing the calculation. So as you can see, by default, the K1 is 1 and K3 is 1. So K3 means I'm relying on delay and bandwidth the most in order to do the calculation. So if you want, you can change any of the other factors as well, but most of the cases, whenever you are implementing EIGRP, this is the default case. Now, if we come back to the formula, just if we just come back to the formula here, so there's a formula that we generally use in order to calculate the metric. So the formula goes something like K1 multiplied by bandwidth. Then we have K2 multiplied by bandwidth. Then this whole thing is kind of like divided by 256 minus load. Then we add this whole thing to something like K3 multiplied by delay. And this whole thing is once again multiplied to K5 divided by K4 plus reliability. And once again, this whole thing is once again multiplied to something like 256. So this is the kind of formula that we generally use in order to do the calculation, or in order to calculate the metric here. So if I just put on the values of K, constant K values, so I know like it goes like 1 multiplied by bandwidth. Then we have here something like K2 multiplied by bandwidth. Then we have 256 minus load. Then we have K3, which is once again 1 multiplied by delay. It's not. And then we have K5, that is once again 0 plus 0 plus reliability. And the whole thing is once again multiplied by 256. Now, if you just know like since here it will be totally become 0, this will also become 0. So the final formula that we get is something going to be bandwidth plus delay, and the whole thing is then multiplied by 256. Okay, so bandwidth when we are talking about bandwidth is something that is known as like when we are talking about bandwidth plus delay, and when you multiply this whole thing with 256, so it becomes something like bandwidth is represented as the reference bandwidth, the maximum bandwidth that is being supported by the EIGRP, divided by the actual bandwidth. Okay, and then we have the delay. So delay is like sum of the delay. So that means we take into account all the delays of the exit interfaces. So I will explain you with the lab here. So we have the sum of the delay divided by the 10, and the whole thing is then multiplied by 256. Okay, so if I just go back to my lab, so I have a lab over here. So this is my lab. As you can see, I have the EIGRP implemented. So if I just bring up my router number 1, and if I just try to show you the EIGRP route, so I have already configured EIGRP on the set of my routers. So if I run the command like show IP route, okay, let me move on to the privilege mode. Show IP route EIGRP. So this is the command if you specifically want to look into EIGRP route. So here we can see that we have certain EIGRP routes to various destinations. So I have the EIGRP routes to network 13. I have the EIGRP routes to network 14. And I also have EIGRP routes to network 20. Now, if you pay attention, I have two routes here. So if you look closely to the routes here, after the network prefix or after the destination network, you can see a few values in the square bracket. So here we can see the AD value. So this is my AD value, and this is the metric. Okay, so this is the metric here. So when it comes to EIGRP, okay, so we don't actually have to do the calculation, like the metric is automatically calculated. But say for some reason, like suppose you might be creating a network, you might be configuring your network, say you might be redistributing external routes into your EIGRP database. So in that way, you might actually, sometimes you may have to do the calculation here. And as a network engineer, you should be aware of the formula, or you should be aware like how the metrics is being calculated. Okay, so we already know what is the bandwidth. So if you don't know bandwidth of your interface, you can just simply go to any of the interface and you can check their interfaces. So when I run the command like show interface, this is my bandwidth. So it's nearly around like 1 Gbps. Okay, so this is it. And here, if I'm talking about the source and the destination, so VPC 5 here is the source and the VPC 6 here is the destination. So in order to reach this, I have two options. So let's say this is my first exit interface. This is my another exit interface, and this one is my last exit interface. Okay. So if we do the calculation part, so we have something like 1 Gbps interface. So when we are talking about gigabit Ethernet interface, so the delay here is generally 10 microseconds. So here we have 10. This interface will also have 10. And this one here, since on my PC, I'm kind of like using a fast Ethernet interface. So the gigabit interface bandwidth is being actually dialed down all the way to 100 Mbps, just to ensure that it is actually able to communicate with the PC here. Okay, so so when we are putting these values into the formula, so the formula will become something like the reference bandwidth. So it will be something like 10 to the power 7 divided by 10 to the power 6. And as of the sum of the delay, like I said, it will be 10 plus 10, 2 gigabit Ethernet. So if I just go back to the lab, okay, so this is one exit interface, gig 0 by 0. Then the other exit interface is gig 0 by 1. And the last exit interface is gig 0 by 2. So these two 10s are for the gig 0 by 0, gig 0 by 1. Then here we have something like 800, because that's a fast Ethernet interface. And here we have the bandwidth as, the delay is 100 microseconds, and this whole thing is kind of like divided by 10. So if you do the calculations here, we know like what the value we are getting. So here we will get something like 10 plus 120 by 10. Okay, and then we get something like the 256. Now, if you just do the final thing, so it will be like 10 plus 12, and the whole thing will be multiplied by 256. Okay, all right, fine. So here I would actually like to make some changes here. So my end device here also we have 10. So it will be something like 30. Okay, and at last we will be getting something like 10 plus 3. Okay, so it will be something like 13 multiplied by 256, and that will get us something like 3328. Okay, so this is the metric that we just calculated. Now if I just go back to the lab, so if I just go back to the lab here, and if I just highlight the routes in order to reach the destination, so my source here is configured with the IP address of 192.168.10.1, and my destination here has been configured with the IP of 192.168.20.1. And if we look onto the details here, as you can see on the bottom here, I can see the EIGRP routes to my destination. So we have two routes. I can go via router number 2, or I can actually go via router number 3. And both the routes has the same metrics here, that is like 3328. Now that is something we actually calculated. So if I just go back to the slide, so here we have the metric formula for, or the metric calculation that we end up with the formula. Okay, so this is it. Now if you don't want to do all the hard work, so say if you want to get all the information regarding your destination, you can run the command like show IP EIGRP topology followed by the destination prefix. So I'm just going to put here 20.0/24, and if I press enter, so you might notice like it is providing me the information regarding all the routes that I have. So here we can see like it is actually showing me the routes for this very network. Okay, so state is passive, and here we can see like the first thing it shows like what is the cost or what is the delay or bandwidth or the metric here to reach the destination via router number 2. So here we can see like this is the composite metric. So this is the calculated part that we also did the calculation. And here we can see what is the minimum bandwidth here, what is the delay here. So in order to reach that particular destination here, we can see the delay is something around 30 microseconds. Okay. And that's it. Same goes for the 12.3. So like I said, in my EIGRP topology, I have two routes in order to reach the destination. So when I run this command, it actually shows me all the routes information. So the first one was route via router number 2. Now the second one that we are looking on to here is via the router number 3. So here we can see like the composite metric is once again 3328. And here also we can see like the minimum bandwidth is 10 to the power 6, and the delay here is 30 microseconds. So if you don't know like what factors to use in your formula, so you can run this command and you will get a detailed output here, and later you can use these values to put on into your formula, and then you can calculate the rest of the metric. Okay, so this is how we generally calculate the metric in EIGRP. Okay, so the metric calculation is a bit complex here in the EIGRP because there it consists of quite a lot of variables and constant values. But when you break down the formula, when you totally break down the formula, just like we did here, so it makes us really easy to understand or remember what the formula that we generally use in order to calculate the metric. So that's all for today, guys. So thank you, everyone. So do let us know in the comments what next topic you guys would like to learn. Thank you so much. See you in the next video.